Have you ever stopped to wonder, is the product you're building powered by predictable, straightforward code, or is it actually running on an autonomous black box? Honestly, it's a question that keeps a lot of product managers up at night. The world of AI, and specifically deep learning, can be incredibly intimidating. It's often talked about in these highly academic terms, shrouded in complex math, and frankly, it can just feel like magic that you have absolutely zero control over. But here's the reality. As a product manager, you cannot manage what you don't understand. So today we're going to demystify that mysterious deep learning black box and give you the actual tools to manage it.
Welcome to This Explainer. I am so excited to guide you through this material today. Our goal here is highly focused. We are going to translate all those complex neural network theories into an actionable framework for modern product management. We're taking the academic and we're making it practical so you can walk right into your next stakeholder meeting with total confidence.
So here is our roadmap for today. 1. Unpacking the black box. 2. Core deep learning capabilities. 3. Real-world product examples. 4. The AIPM playbook. And 5. Model interpretability and trust. All right, Section 1. Unpacking the black box. Theory and foundations. Before we can even think about managing an AI product, we really need to nail down the foundational theory. The engine behind deep learning is something called a deep neural network. And write that down because this is the exact terminology you'll need for your engineering syncs. Basically, a neural network is a mathematical model structured a lot like the nerve cells in a human brain. The deep part, that just refers to the fact that it has multiple hidden layers sitting between the input and the output. During training, raw data passes through these hidden layers, and the network autonomously learns increasingly abstract representations of that data. It's literally learning the patterns all on its own. Okay, let's dive into this because this represents a massive paradigm shift. In traditional machine learning, your engineers have to manually select the features, meaning they actually have to sit there and tell the model exactly what to look for in the data. It's a much simpler, much more transparent process. But deep learning selects its own features autonomously through those hidden layers we just talked about. It figures it out with very little input from an engineer. Now, this is incredibly powerful, but it's also exactly why it's considered a highly opaque black box. The network is making computational decisions so rapidly across so many different layers that even the brilliant engineers who built it often can't see exactly how it arrived at a specific conclusion. Which brings us to Section 2, Core Deep Learning Capabilities. What can the box actually do? You might be wondering, if deep learning is so complex and opaque, why even use it? Well, recent business model research outlines 4 core capabilities that you can leverage. First up, high predictive precision. This is about making incredibly accurate forecasts based on massive data sets. Second, recognition of patterns, finding those hidden insights in customer behavior or operational inefficiencies that humans would just naturally miss. Third is real-time insights. Think monitoring vast data streams to detect trends instantly. And fourth, automated decision-making, which drastically speeds up processes like dynamic pricing or loan approvals with minimal human intervention. And this brilliantly illustrates how those 4 theoretical capabilities fit right into the bigger picture of your business model. Notice how those core functions, predictive precision, pattern recognition, real-time insights, and automated decisions feed directly into your business configuration. They're the engine driving your strategic planning, your operational efficiency, and ultimately your customer engagement. Deep learning isn't just some fun tech feature to slap on a roadmap. It's a strategic enabler that completely transforms market responsiveness and the end-user experience. Moving on to Section 3, Real-World Product Examples, from Capabilities to Commerce. Now, what's really fascinating here is how directly these technical capabilities map out to measurable business impact. Take a look at Walmart. They leverage high predictive precision to forecast demand for seasonal products, which directly optimizes their supply chain and massively reduces waste. Then you have Netflix. They use pattern recognition to analyze mountains of viewing habit data, providing personalized recommendations that significantly increase customer retention. And Uber? They rely on automated decision-making to dynamically adjust ride prices based on real-time supply and demand, maximizing their revenue on the fly. This is exactly how you translate that intimidating black box into a rock-solid business case. Let's look at one more highly specific example to really put this into perspective. 84.01%. A recent study out of Concordia University actually designed a deep learning model to predict the overall rating of laptop products on Amazon.
by using natural language processing to autonomously extract custom features, so the things customers actually care about, from online reviews, and then combining that with general product specs, their deep learning algorithm achieved an 84.01% accuracy score in predicting the product's final popularity. Just imagine the product strategy you could build if you could predict market reception with 84% accuracy. It's a real game changer.
All right, Section 4. The AI PM Playbook, Navigating the Daily Reality.
So, how do we actually build this thing? AI product management is a highly iterative process. It's so much more fluid than standard code deployment. First, you start by defining the scope using concrete examples. If you're building, say, a banking chatbot, you don't just write a vague spec document. You write 10 to 50 actual conversational examples that you want the bot to execute. From there, your ML engineers train and tune the models on historical data. Next, you don't just ship the model into the void. You deploy the machine learning output seamlessly into the broader UI and UX of your existing product. And finally, you continuously iterate based on the feedback loop. The model learns, the data changes, and you adjust. And that leads me to this absolutely fantastic quote from the team at deeplearning.ai. The data is your PRD. Literally, let that sink in for a second. The traditional product requirements document, your PRD, is fundamentally being replaced by data. Just as a machine learning algorithm needs training examples to learn from, your AI development team needs concrete data examples to know what to build. It's a massive paradigm shift in how you scope your products. Now, for our final section, Section 5, Model Interpretability and Trust, the dark side of the box. We've got to talk about a crucial concept here, model interpretability. This is defined as the ability to understand, debug, and explain exactly how a complex deep learning model arrives at its specific predictions or decisions. So why does this matter to you? Well, because if you are deploying AI in high-stakes fields, think healthcare diagnostics or finance, your stakeholders absolutely need to trust the model. You need interpretability for legal compliance, for detecting hidden biases or flaws in your data, and honestly, for simple debugging when the model inevitably gets something wrong. Knowing what your options are for creating this transparency is absolutely vital. Engineers generally tackle this in two ways. First, there's intrinsic interpretability. This means using models that are inherently transparent right from the start, like simple decision trees or linear regression. The downside, they usually can't handle complex deep learning tasks. That is where post-hoc interpretability comes in. This means taking your complex, fully trained deep learning black box and applying external post-training techniques to try and explain its behavior. As a PM, you need the exact vocabulary to demand accountability from your engineering team. So here are a few post-hoc tools they might use. Feature importance techniques like SHAP or LIME actually calculate which input data had the most influence on a specific prediction. Saliency maps are used in computer vision to visually highlight exactly which parts of an image the model was focusing on. Activation maximization visualizes what input patterns activate certain neurons, kind of showing you what the model's looking for internally. And surrogate models involve training a simpler, transparent model to approximate the predictions of your big, complex deep learning model. Asking your team for these techniques ensures that you aren't just flying blind. So, we've covered the foundational theory, the massive commercial capabilities, the shifting PM playbook, and the tools you need to finally peek inside that black box. But when all is said and done, it all comes down to this lingering question. Are you ready to take stewardship of an AI product's ethical footprint? Managing deep learning is an incredible balancing act between driving cutting-edge commercial innovation and ensuring rock-solid reliability and trust for your users. It's definitely a challenging space, but armed with this framework, it's a space you are now fully ready to lead. Thanks so much for joining me on this explainer, and hey, keep learning.